none left over. Show your thinking using pictures or arrays. Then write a number model for each of your representations. I want you to work with your table. Figure out how many cartons do we need for our 16 bottles of juice. I'm leaving the math message up on the board so you can refer back to it, but I want you to work this out with your table. So you should be having a accountable talk with everybody at your table. Would be in each carton?
4.
Why would it be 4?
Because 4, 8, 12, 16.
There you go, yeah. Is there another way that
4
we
times
separate our bottles into our juice cartons? How? Okay, so how many groups of 2 would we need to get to 16?
4 times 4.
Pictures. We would need 8 groups of how many? 2, exactly. Okay, am I done? Is this the only way?
No.
What else can I do, Annabelle?
Do 2 groups. 8 groups of 2.
8 groups of 2. Okay.
Yeah, but I don't think so. We'll carry that many bags.
So I think Joanna is super strong and she's going to carry how many bags she needs as long as there. Is this the only way I could solve my problem? We've done 3 ways already. How else could we do it, Hope? Okay, I could do a 4x4 array. Absolutely. It did say pictures or arrays. But guys, is this the only way I could solve the problem? Am I done?
No.
Okay. How else could I do it, Dalton?
4 plus 4 plus 4 equals 16.
We could, but remember, it says show your thinking using pictures or arrays. That would be a problem. What other pictures can I draw? Sidon, do you have something different?
Draw 16 groups of 1.
16 groups of 1. Could I also Could I also do 1 group of 16?
Yes.
Yeah, I can, right?
Yeah, but she's probably 2 groups of 2.
Okay, so everybody look up on the board. Look up on the board. There are also many other ways we could solve it, but I'm running out of room here, folks. Turn and tell your everybody, why is there numerous ways that we could solve this? Why do you think?
Because we
Why do you think?
point of view.
Turn and tell your everybody.
Because we have different point of view.
It's math time.
No, it's math time. Because there's different ways to solve it.
Say that again.
There's different numbers that you could start from to make the number that you're trying to get to. Because there's so many ways.
Solve this problem so many ways. Why can we solve this problem in so many ways? Annabelle?
They're all the same fact.
They're all in the same fact family. So 16, that's our product. That's what we want. We could do 2 times 8. We could do 4 times 4. We could do 2 times 8. It's all in the same fact family, right? Yeah. Do you have something to add, Simon?
Also, we all have different point of view.
Look at you are just tying in ELA. I don't know if it has to do with point of view. It's more mathematical, but I love that you're excited for ELA this afternoon. Wells, what do you think?
You can start from different numbers so they can get to the number that you're trying to get to.
Yeah, absolutely. You can start with a number and you can keep adding that and adding that and adding that, Adelaide, until you see if you can get to 16, right? But it all has to be equal because they're all a part of a fact family. Hope, did you have something to add?
There's different ways to get to 16.
Yeah, there's different ways to get to 16. I want you you to look at your multiplication chart, either in your binder or on your name tag. I want you to count how many different ways can we get to 16 using our multiplication chart. Look on your multiplication chart. How many ways can you or can I get to 16 as our product? Together, we got 16. What is one that you found, Bird?
4 times 4.
4 times 4. That gets us to 16. What's another one you found, Natasha? 2 times 8. Is there another one? Is there another one? Hope? 6 times 3. Absolutely. Is there another one? Cameron?
There's 8 times 2.
8 times 2.
2 times 8.
Or 2 times 8. You can flip them. What about, is there another one? Zaida?
18 times 1. 16 times 1.
There you go. We're doing 16. 16 times 1. Absolutely. So I want you now to turn to page 259. And we are going to continue looking at the factors of our products. One and a half. And everybody needs to be in your seats and turn to page 259. If you are already at page 259, then you need to read the directions. That way, when we are all ready, you guys are ready to roll. Read the directions. 259. Everybody needs to be looking at the directions. We're not coloring on our pencil cases. We're not sharpening our pencils. We are reading the directions on page 259. My boys in the back, I need you in your seats. We don't need a marker anymore. We just need a pencil and 259 in our workbooks. Thanks for joining us. Okay, so for each problem, we need to fill in the blanks with different factor pairs that make the number sentences true. So y'all just went on your number line and you guys found different factor pairs to make our number sentences true. So look at number 1. Our product is 8. So using our multiplication charts, or even just in our schema, pulling out these facts, I want you to see if you can find 2 multiplication sentences that make this problem true. What times what equals 8? What's one that we could do? Willow?
2 times 4.
2 times 4. Absolutely, that does equal 8. Is there another one we could do? Is there another one we could do? Mason? 8 times 1.
Yeah, that's what I
Is that what you said? 8 times, okay.
We're going to do everything.
8 times 1. Absolutely. So what I'm writing on the board, you are writing where? On your page, on your paper, in your workbook. All of the above.
It doesn't matter which way you roll it.
Hold on, I just got a really great question. Can you ask it again?
I know it doesn't matter, but since they're drawing it that way, you have to draw the exact same way that you were drawing it.
So are you asking, I put 2 times 4. Are you asking if you could put 4 times 2? Turn to tell your elbow buddy, does it change my number sentence if I flip my numbers? If I flip my, friends, if I flip the numbers around, does it make a difference? No, it doesn't. So if you want to put 4 times 2, go right ahead. If you want to put 1 times 8, go right ahead. Just as long as you can prove that that number sentence is going to be true. So look at the next one. We need to find and make these number sentences equal to 18. Look on your multiplication chart if you need to. You could use our skip counting numbers. You can use your mental math. And I want you to think, raise your hand if you have two factors that we can multiply together to get 18.
Oh.
You're not working ahead. If you're working ahead, I need you to erase it. Sorry. What can I do? What factors can I use, Audrey, to make my number sentence true? 9 times 2. Or 2 times 9. Turn and tell your elbow buddy, work out the next one together.
6 times 3.
What are two factors I can plug into my number sentence to make this true? Tyrell? 6 times 3. But is there another one? Is there another one I can put? Is there another one I can put back in?
3 times 6.
3 times that we can flip it, but is there another one that uses different factors? Cameron?
18 times 1.
We could also do 18 times 1, absolutely. So now, with your elbow buddy, I want you to do 3 and 4 together. When I walk around, I need to hear accountable talk between you and your elbow buddy. Not just one person taking the lead. I need you to do it together.
Don't take your break now.
You are doing 3 and 4 with your elbow buddy. I need to find a factor pair to make this true. What can I do, Bert? 9 times 3. For the next one, can I do 25 plus 2? No, I can't. You're right. I have to do a factor pair. What else could I do, Kanata?
1 times 27.
Absolutely. 1 and 27. Is there anything else I could do? Is there anything else I could do? Adrian?
12 times 3.
I'll come back to you for number 4, but we're on number 3. Number 3, is there anything else I could do? For 27? Kanata?
You can flip-flop it.
We can flip-flop it, absolutely. You could also put 3 and 9 or 27 and 1, but it still makes it true. And there's nothing else we can do for 27. So let's look at number 4. Number 4. Our product is 36. We need to find a faster pair. What can we do, Adrian?
12 times 3.
Absolutely, we can do 12 times 3. Let's see, what is another one that I could do? I want to challenge you. What's another one I can do that's not 1 times 36? Oh, there's other ones I can do. What is it, Tyrell?
6 times
6 times 6.
6. Ugh. Ugh.
Hold on though, friends. I think there's some more that I could do, right? What's another one I could do, Natasha? 18 times 2. We know we could do 36 times 1. But there's another one I'm thinking of. What is it, Mason?
9 times 4.
9 times 4. Awesome job. Now, I would like you to do number 5 on your own. Do number 5 on your own. Our product is 45.
the multiplication chart is I know what you're gonna ask. Are you gonna ask about number 6?
Number 6, number 6.
That's a factor more. Okay, number 5. Our product is 45. What factor pairs can I use? What did you put, Haley?
You could put 5 times
5
9.
times 9. Absolutely. What's another one? What's another one, Olivia?
1 times 45.
1 times 45. Is there another one I could do that's not flip-flopping any of these numbers? Adrian? What'd you do?
9 times 5.
Yeah, 9 times 5. We can also flip-flop them. Absolutely. Okay, friends, let's look at number 6. I need you to read number 6, and once you read it, I need you to give me a nice big thumbs up high in the sky. Read number 6. Could have one table with 24 people, or 2 tables with 12. It gives us that total. If you keep on going, it says, what are some other ways? So Miss Kim knows she could have 1 table with 24, or 2 tables with 24. Oh, it's a little much. So Miss Kim wants to know if she could seat people differently inside her dining room. She must have a really big dining room. How else could we group together our tables? Give me one way, Dalton.
You could do 2 tables and one has 23 people and one has 1 person.
Okay, I like that you said that because remember, it gave us a hint. It says think factor pairs for 24. If we do, what did you say again, buddy?
1 table with 23 people and 1 table with 1 person.
Okay, that would be an addition problem, right? Fact pairs. What types of problems are those?
Times.
What?
Times.
Yeah, it's multiplication. So we are using the skills we did in our math message and the skills we did in 1 through 5. So what are some factor pairs we could do for 24? I like that you said that though, Dalton, because a few other friends did too. And I want to make sure we're all on the same page. What's one we could do, Audrey?
What we could do 6 tables with 4 people.
We could do 6 tables with 4 people each. I know, she must have a huge... Okay, so we know she must have a lot of tables and a lot of room in that dining room, Willow. How else could she group her 24 dinner guests? Adrian?
We can do 6 with 4 tables and 6 people in each table.
Yeah, we could do 4 tables of 6, absolutely. That's just flip-flopping. But we absolutely can. What else could I do? Frankie?
3 tables of 8.
3 tables of 8. What else can I do? Hope?
12 tables with 2 people on each table.
Say that one more time.
12 tables with 2 people.
Okay, so we just said 12 tables with 2 people each. But remember, it already said Miss Kim could have 1 table with 24 people, or 2 tables, my bad, with 12 people each. But she decided that's too many people at each table. So she wants to see if she can get less people at each table. Is there anything else I could do? Wells?
Oh, never mind. I was
Okay.
thinking one that they already did.
Okay. Annabelle?
3 tables with 8 at each.
3 tables with 8 at each. Oh, we already did that one. Let's see, everybody look on the board, see what we already did. We already have 6 6 tables with 4 people. We already have 4 tables with 6 people. We already have 3 tables with 8 people each. What else could I do? Cameron?
You could do 12 tables of 2.
Remember, everybody listen. Miss Kim already knows that she can have 1 table with 24 people. Miss Kim also already knows she could have 2 tables with 12 people each. So we already know we could do that. But Miss Kim said, that's way too many people at each table. So, although those factor pairs are right and it makes it true, she wants to see if we could get any smaller factor pairs. Hope?
8 tables of 3.
Yeah, we could do 8 tables of 3 each. Alrighty, friends. So, good job with this problem. I know it was wordy, but you guys did a good job. I want you now, think back to what you did with Miss Johnson on the carpet yesterday. Think back to what you did with Miss Johnson on the carpet yesterday. I wasn't there with you, friends, so I forgot how to do this. It's been a while since I was in 3rd grade. I need your help. 200, that's our product. We need to find a factor pair to make this number sentence true. Our product is 200. Turn and tell your elbow buddy, what are 2 ways I can solve? Turn and tell your elbow buddy.
250 times 2 times 2 times and then you can also I like that.
Good. What are you thinking over here, boys? I forgot. I didn't know it was that simple. What do we think? Ooh, very true. What do you guys think? Alright guys, you know it's been a long time since I've been in 3rd grade. You know it's my first time teaching 3rd grade. I forgot how to do this. My product is 200. What factor pair do I do? Right. What's one I could do, Mason?
20 times 10.
Oh, 20 times 10. Okay. Absolutely. Because 2 times 1 is what? Class, what's 2 times 1?
2.
2. And I have 2 zeros, so I just add those zeros on, and that makes 200. Absolutely. What else could I do, Miss Adelaide?
1 times 200.
We could do 1 times 200, but I want to see if I can think a little harder than that. What else could I do, Tyrell? 2 times 100. Let's see, I'm thinking about one more that I could do. What is it, Hadley? Oh no, you can do 50 times 4. Awesome. Awesome. What else could I do, Frankie? You think there's more I could do? Hold on. Baby, next time pick it up, because I can hear anything Frankie just said. What else?
25 times 8.
Ooh, I could do 25 times 8. I like that. I didn't even think about that one. Absolutely. What you would do for number 8. See if you could try this one on your own. See if you can try 8 on your own. I just want you to try it for 30 seconds. Our girlfriend, I just wrote 1, 2, 3, 4, 5 different answers for number 7. What are you doing?
The question of the day was some of them. What are you not doing?
Little do they know I'm gonna edit this video tonight and be like, you weren't paying attention, you weren't paying attention. I'll remember.
Hey, they want to take their playtime now, so when it's time for playtime, I'll just have them do it then. No problem. I'm recording for her teacher right now. Thank you.
Quickly, I want to hear 2 different ways I could do this problem. 720 is my product. What factor family could I use, Hope?
12 times 60.
12 times 60. We know that 12 times 6 gets us to 72. So by adding that 0 onto our 60, that gets us to 720. What is one more I could do, Frankie? 90 times 8. We know 9 times 8 is 72. So adding that 0 to the 9, making it 90, makes it 720. Okay, friends, Leia said it is field trip time, but
For some of us.
for some of us. But what I need you to do now is quickly